Hello everyone in CSC-134. This is the video that talks about the most efficient way to sort things that your textbook does not know about. And that is the algorithm library sort function. So I'm in module 7 in Blackboard. And if you scroll down, you can see this folder where I'm going to put this video as well as on the checklist. But the code for this video is going to be inside this folder and then inside of a folder for the algorithm library search. Now, there are 3 separate videos and 3 separate lectures inside this folder. So I'm going to click in there and you can see I've got all the source code at the top. I've got the bubble sort and the code for that is behind this link. The selection sort and the code for that's behind that link. And now I will put this video here in this area, and the algorithm library code will be in that folder as well. So let's go get that code and play with it a little bit. So I've shown you the algorithm library functions to sum up an array. I've shown you the algorithm library functions to search arrays. And now I'm showing you the algorithm library function to sort arrays. And this is really almost one line of code. Here I've clicked into the text about it, but you can kind of see, if you wanted to go back and look at this, that you have to include the algorithm library at the top, and that's not any different from what we have done in the past when we were going to use it. This item here in red is important because if you're going to pass an array to a function that's using the algorithm library, you have to specify your array like this so that it can be iterated through. So let's get that code, and then we can talk. You'll see just how short it is. It's ridiculously short compared to what was going on with the other things. So I've saved that down to a folder here in my downloads. I'm going to open it up with Genie. Alright, so right here you can see that I have included algorithm. You have to tell it with a constant how big your array is. In this particular case, we've got 90 things in that array. And here's the array. And as you can see, it's definitely not sorted. In fact, this array would require almost every element to be touched if it was being used with a bubble sort, because if you watch that video of the bubble sort, it goes through the array looking at 2 elements. The first 2 elements, it would look at these and say, nope, these don't need to be sorted because 5 comes before 52. It'd look at these 2 and say those 2 don't need to be sorted. It'd look at these 2 and say those don't need to be sorted. It would get all the way over to right here when it saw 68 and 40, and it would say, oh, I need to switch those because 40 comes before 68. And then it would get to these and it would switch the 3 in front of the 84. And so it'd work its way all the way through all those elements. And then because it had to switch to, it's going to start back over at the beginning and look through them all again. And it's going to keep doing that until it doesn't have to swap anything. And so if it makes it all the way through without having to swap any elements, then it knows it's done and the elements are in order. That's the bubble sort. Now, we're doing a binary sort. So a binary sort is your most absolute, most efficient way, and it uses a binary tree algorithm to sort very efficiently. So here is the one line of code to do that sort. Compare that to the code that's required to do a bubble sort or the code that's required to do a selection sort. This is one line of code. Here's my function that I called asort for algorithm sort. Okay, here's where we're saying that our array is going to be of integers, but here's that special code that I told you about that you have to do. We're passing the array in by reference, and we're giving it the size here. So you'll see a prototype up here. There's our function prototype for the algorithm sort. Okay. Only difference between the prototype and the actual function header is we had to tell it the name of the array that we're going to call it inside the function. So here's that one line of code. The sort function in the algorithms library is a binary sort. You pass it the array, the beginning of the array, and you pass it the end of the array, and when this thing is done, it's all in order. So right here, here's the array. This loop, this little for loop, is just going to show us what the array looks like before it was sorted. Here we're going to sort it by calling the asort function, passing the array in. You can see right here the name of our array was values. We're going to pass it in, and then we're going to roll through it again to show you that it's sorted. So I'm going to go ahead and compile this program and build it. You see it built successfully. Now I'm going to run it. Okay, here's the unsorted array. You can see nothing's in order. And look at how pretty our sorted array is. And you can see it ran really, really fast because it did a binary sort. So that is how you use the algorithm library to do a binary sort on an array. Now, all these comments that I put down here in my function when I wrote it, I just said that if you want it to sort descending so that the biggest number would be at the front and the smallest would be at the end, then all you've got to do is uncomment the function that you want to. If we want it to, it defaults to sorting ascending like you saw. Okay, so it's implied that it's already got that comma and the less than, and if it's an integer you'd want to put int inside there. You don't have to put this on the end of it if you want it to be sorted ascending. But if you needed to have it go descending instead, this is what you would put on the end of it, or just uncomment that line, and then you've got a descending sort. Of course, we'd need to comment this line out, and we can do that and build it just so you can see that it works. So this is going to do a descending sort. So I'll build that again and run it, and now you see my values are sorted descending instead of ascending. So very cool stuff, very easy to use. In the real world, there's absolutely no reason why you would be doing all that code that I can think of anyway. So that's the algorithms library search. Remember, it does a binary search, and you've got the code for it. You've got the reference articles, and that's the end of this video on the algorithm library sort in C++. Have a good week.